Hi there, in this video I'm going to talk about the sigma and pi bonds. This is my 2D diagram of vanillin, and it's much easier to see the intermolecular forces, the hybridization, and the bonds. So everywhere in purple, so these CH bonds, these CC bonds, this OH bond, everywhere that's purple, they are all sigma bonds, as indicated by this little Greek symbol here. All of these green bonds up here over by the aldehyde group, in here on the benzene ring, these are all pi bonds. They're indicated by green, and this is because there's a double bond, so the first one would be a sigma and the second one is a pi bond. So next is the hybridization of each. This is written in black around each central atom. So every single carbon, central carbon, including the aldehyde group and discluding this one down here, they are all sp2 hybridized. This is because each one has three things around the central atom, which gives it a steric number of 3. When the steric number of a central atom is 3, it makes it sp2 hybridized, which is indicated here, sp2 hybridized. So this means that it gives the trigonal planar Vesper geometry. That's the word I'm thinking of, Vesper geometry. Down here, though, we have 4 things around the central atom, 2 bonds and 2 lone pairs. So 4 things makes it an sp3 hybridized orbital, which means it has the ability to bond with 4 things, because it has a steric number 4. Over here, also, we have sp3 hybridized because it has 4 things around the central atom. 2 lone pairs, 2 bonds. This one, 4 bonds. Next, we're going to talk about the intermolecular forces found. So, this molecule is polar. Vanillin is polar. This is because of this strong hydrogen bond occurring down here. And not such a strong hydrogen bond, but still enough to make it polar, have poles up here and in here. Well, not poles, but it has a positive inside, negative, negative. So these hydrogen bonds make it have the ability to bond with other vanillin molecules. So I'm going to talk about each bond individually. So I just talked about the hydrogen bond. All the CH bonds, these ones, they are a covalent bond because their partial difference is 0.4. The CO bonds, as located up here in the aldehyde group, they have a polar covalent bond because C's is, I believe it's 2.5 and oxygen is 3.5, which its electronegativities, its difference is 1, so it gives it a polar covalent bond. All of the CC bonds have absolutely no partial charge because they're the same, so there's no differential electronegativities. So this atom in a whole, this molecule, can have all 4 forces: van der Waals, dipole-dipole, Leonard dispersion forces, and hydrogen bonding. And that's all I can tell you in this video. Hope you enjoyed that. I'll have another one.